Hey everyone, and welcome. Today we're jumping into something that's at the absolute heart of building any app people can actually use, Java Event Handling. We're going to find out how to make your code snap to attention and respond to every single click and key press. So picture this. You've spent hours, maybe days, getting your GUI to look perfect. The buttons are just right, the layout is clean, but then you run it. You click the button and nothing. It just sits there. It's a super common roadblock, right? Well, that missing link, that magic piece that connects a static image to a dynamic app, is exactly what we're going to uncover today. Here's the game plan. We'll start with why our windows are static in the first place. Then we'll check out Java's really slick solution. We'll meet the three key players involved, see how they handle user actions, and I'll wrap it up with a pro tip about adapter classes that you're going to love. Let's do it.
Okay, so first things first, let's really understand the core of the problem. Why doesn't a button just work right out of the box? Here's the thing you've got to get. A GUI component, like a JButton, is basically just a pretty picture. It's passive. You can click it 1,000 times, and while it knows it's being clicked, it has absolutely no idea what to do about it. There are no instructions. To bring it to life, we need to attach something that's actually listening for that click. So how did the creators of Java solve this puzzle? They came up with a really clever system, and it's called the delegation event model. And honestly, the name tells you everything you need to know. Instead of making the button handle its own click, it delegates that job to a totally separate, specialized object. The button's only job is to shout, "Hey, I just got clicked," and pass that message along. This is so smart because it keeps things clean. You can change what happens when you click the button without ever touching the button's code itself.
Think of it like ordering food online, right? You clicking the button, that's you placing an order. The button itself is like the restaurant. It gets the order and packs it up into a little data package. We call that an event object. But here's the key. The restaurant doesn't deliver the food. It calls a delivery agent. That's our listener, who is specifically signed up to handle its deliveries. The listener grabs the package and does the work. In our case, it runs your code.
All right, so let's properly introduce the three stars of this entire operation: the source, the event, and the listener.
First up, we have the source. This is just your GUI component, plain and simple. It's the button you click, the checkbox you tick, the window you try to close. In this whole model, its only job is to create an event when something happens to it. That's it. Next up is the event. This is that package we were talking about. And it's not just an empty signal. It's a full-blown Java object. It's packed with useful info, like which button was clicked, the exact X and Y coordinates of the mouse, or which key was pressed on the keyboard. And finally, the most important player, the listener. This is our delivery agent. It's an object that we create, and its whole purpose in life is to just wait for a specific event from a specific source. To do this, it has to implement a special listener interface, which guarantees it has the right methods ready to go, like action performed, the second that notification comes in. And this is the magic glue that holds it all together: registration. You have to explicitly tell the source about its listener. This one line of code is you saying, "Hey button, when you get clicked, I want you to notify this specific object right here." If you forget this step, the source has no one to delegate to, and we're right back where we started with a button that does nothing. Okay, theory is done. Let's see how this awesome model works with the most common things a user will do, using the mouse and the keyboard. Now this is where it gets really cool. Look how specific Java lets you be. If you want to handle mouse actions, you use the mouse listener interface, and it gives you all these methods. You can write code that runs only when the mouse enters a component or only when it's released. Same for the keyboard. Key listener gives you pinpoint control over when a key is pressed, released, or typed. And the logic is just so direct and beautiful. The source creates the event, and the Java system automatically calls the right method in your listener. You press a key, bam, the key pressed method in your listener runs. You click the mouse, boom, mouse clicked gets called. Your only job is to put your logic inside the right method. Okay, you get the model. You're ready to code. Now, let me give you a pro tip that's going to save you a ton of time and make your code way cleaner. Let's talk about adapter classes. So you've probably run into this. It's so annoying. You want to do one simple thing, like run some code when the user closes a window. So you implement window listener, and suddenly your IDE is yelling at you to implement 7 different methods. You only care about window closing, but now you have to create 6 other empty, useless methods just to make the compiler happy. Ugh.
Well, what if I told you there's a way around that? Meet the adapter class. An adapter is a wonderful little helper class that's already done all the boring work for you. It's a class that already implements the listener interface and provides empty versions of every single one of its methods. Just look at the difference. It's night and day. On the left, if you implement Mouse Listener, you're forced to write out all 5 methods, even if you only need mouse clicked. But on the right, you just extend the mouse adapter. Now you only have to write the one method you actually care about. The result is exactly the same, but the code is so much cleaner. And this isn't just about typing less. It's about writing smarter, more readable code. Your class is now focused only on the job it's meant to do. It's shorter, it's easier for you or someone else to understand later, and there's no useless clutter. It's an absolute game changer.
All right, let's wrap this up with the key takeaways. We started with a GUI that did nothing. We learned Java's fix is the delegation event model, which follows a simple flow. A source creates an event which gets sent to a listener. The source is your button, the listener is your code, and the absolute key is that you have to register the listener with the source. And for bonus points, you now know the pro tip. Use adapter classes to keep your listener code lean and mean.
And there you have it. You now have the fundamental building block for creating truly interactive applications in Java. Your components are no longer just static pictures on a screen. They're doorways. They can listen. So the only question left is, what are you going to make them do? Thanks for joining me.